Right, here we are again. Right, with this question, we've got a tapering pipe, which means it looks a bit like this. Okay, pipe, tapering. So it looks something like that. So it's big diameter there and a small there. Okay, there's the pipe, and it's got stuff coming through it. It's got stuff coming through it like that. And we need to work out a couple of things. Get a blue one. So we know inlet diameter of 55 millimeters, which means the diameter here, let's see if we can move this down. No, okay. The diameter here is 55 mil. And the velocity here is 2 meters per second. And we know that the symbol for velocity for this type of thing is C. It's the inlet, so we put C1. That's going to be 2 meters a second. 2. The outlet velocity of a liquid is to be 6.5. So we need C2, because C2 is the outlet velocity, to be 6.5. It's going to get faster. Because again, faster, that suggests that the diameter of the pipe on the way out is going to get less. Because there's less space for the stuff to get out, so it's got to get smaller. The density of the liquid is 960, so the density, symbol for density, is 960. So there's our things we know. 55 mil, 960, 2 meters, 6.5. We've got to find the mass flow rate. That's the first thing. Okay. So the mass flow rate, we know that the formula for mass flow rate is something like this. M dot is density, area, speed. So M dot is mass flow rate, density, area, speed. Okay, so we know the density, tick. We know the density. We know we know C1 because it's 2, and we know A1 because A1 is the area coming in. So that's A1 over here. Look, we know that because we can find it from this diameter. We don't know A2, so we can't use that. So to find the mass flow, don't forget the mass flow rate is the same in and out. Whatever it is, it's constant. So the mass flow rate is going to be, let's get a different color pen, just black. So part A, the mass flow rate is going to be M dot, is going to be density, which we know is 960, A1, which we'll work out in a bit, times by C1, which is going to be 2. So we need to find A1 first. So A1 is the area in, the inlet area, the area of the pipe coming in, pi r squared. That's what we can use. Okay. Or you could use, if you know this one, you could use pi d squared over 4. Depending on which one you want to use. Both will give you the formula for the area of a circle. So we've got 55 mil, which means, let's go down a bit. So diameter is 55, which means the radius is going to be 55 divided by 2, which gives you 27.5 millimeters, We can't be in millimeters, we've got to be in meters. 1,000 millimeters in a meter. So if you divide that by 1,000, okay, so the radius we're going to be using is going to be 0.0275. That's our radius, which means the area is going to be pi r squared, which is going to be pi times by 0.0275 squared. I'm now going to put it in this formula here. That will give us the mass flow rate. So let's get a different colour pen, because that one's getting on my nerves. Let's get a different colour pen here. What's going on there? I don't know. What's going on there? Get a different colour pen. Green. Let's use green then. Come on. Green. Okay. So mass flow rate is density A1 C1, and we know the density is 960 there. So I'm going to put 960 in, times by the A1, which is this. Let's put a bracket around it so your calculator doesn't give you a funny number or syntax error. Pi r squared, look, that number there, times by the speed coming in, which is 2, I think. 2. So times that all together, and that will give you the mass flow rate, which will be part A done. Put that in your calculator and you get something like 4.56 kilograms per second. That's the mass flow rate, part A done. All that means is that we've got 4.56 kilograms per second coming through this pipe. Okay, it's 4.56, which means it's 4.56 coming in, and it's 4.56 coming out. Okay, that's part A done. Part B coming next. Part B. For part B, we've got to find the outlet diameter of the pipe. So in part A, we did the mass flow rate. Give it some stuff here. So now we've got to find the outlet diameter. That means we've got to find, get a pen, got to find the diameter of this bit there. Don't know what that diameter is. We know the diameter coming in is 55. We don't know the diameter on the way out. Okay, put that off, don't confuse you. Put this back here, look, that was A2. That's probably A1, I think it was, wasn't it? Right. So we've got to find the outlet diameter of the pipe. Okay. So B, so we've got to find the outlet. What's the diameter, right, of the outlet part of it, right? So if I draw it again, look, okay, it's getting smaller. It's a tapering pipe, it's getting smaller. So it's like that, it's like that. I got to find the diameter here. Okay. Now, I know this formula. I know mass flow rate is density, area, and speed, just like we've done before. Okay. Now, luckily, in part A, we worked out the mass flow rate. It was 4.56. So mass flow rate is 4.56 kilograms per second. That's constant. So we've got 4.56 coming there, and it's 4.56 coming out. That's what we've assumed, the continuity equation. So if we know the mass flow rate coming out, we can use that. So we know it's 4.56. So in this formula, I know the mass flow rate, I know the density, I know the speed. I don't know the area. If I can find the area, I can then find the radius, because I know the area of a circle is pi r squared. If I can find the radius, I can times it by 2. That'll give me my diameter. So that's what we've got to do. Got to find A2, because this is area 2 coming out. Right? So I need to find, or I need to work out, not work out, but it's been given somewhere, what's my speed coming out? If I go up, it says here, tapering pipe has an inlet diameter of 55 and an inlet velocity of 2. If the outlet velocity of the liquid is to be 6.5, that means I want, different color here, I want 6.5 meters per second to come out of the end. Okay, so here's my formula. Mass flow rate, which we know, equals the density, which we know, area, which we don't. I'm going to call it area 2, because it's the outlet, times by outlet speed. So C2 is the outlet speed, A2 is the outlet area, density, and the mass flow rate is the mass flow rate. Because here's my pipe. Here's my pipe. It's a round pipe. Doesn't look, that's a bit odd, isn't it? Okay, so I need to find the diameter of this bit here. Here we go. Mass flow rate. I know my mass flow rate is 4.56 because we worked it out earlier on. I know the density. The density is 960. Okay, so 960 times by, I don't know what the area is, A2. Don't forget A2 is the outlet area. And the speed coming out, or the velocity coming out, is 6.5 from the question. 6.5 there, look. I need to find what A2 is. So all I'm going to do now is rearrange this formula. I'm going to leave the A2 here and get a different color pen. So I'm going to do this. 4.56, I'll leave that there. 960 and 6.5 are all multiplied, so the opposite is divide. So I'm going to divide all of this by 960 times by 6.5. You might perhaps want to put a bracket around that, depending if you use a calculator. It's 4.56 divided by all of this. That should give you something like this, depending on how you're doing it. If you press the E and G button or your calculator, if you're using a phone, you might get a different number. Well, you won't get a different number, just different format. Okay. So 4.56 divided by all of that gives me this. That is A2. It's an area, so it's meters squared. That's quite handy, because now I know what A2 is. I know the area coming out is that number, 730 times 10 to the minus 6, which is quite small meter, isn't it? But I've got to find diameter. I don't know what diameter is. I don't know what it is. But I know the area is pi r squared. And I know that my area is 730. So I can do this. 730.77 times 10 to the minus 6 equals pi times r squared. Because I know that area is pi r squared. Trying to find the radius and times it by 2, see? So I need to do a bit of rearranging, or I need to move a few things down. Let's give you in glass. So I'm going to leave the r squared there. That pi is multiplied by, so I'm going to do this. 730.77 times 10 to the minus 6. Now divide that by pi. cherry pie. That will give me r squared. I'm going to do one more thing. So that's a square by there, look. So the opposite of a square is a square root. So if I square root all of this, doing a calculator. So if I square root all of this, don't do it in your head, as you can, all over pi. It's all of that. Catch my drift? That will give me my radius. That will give me my radius. And I know that diameter is is radius, isn't it? Times 2. So radius times 2, isn't it? Radius times 2 gives you diameter. So all I've got to do is work this here out, times it by 2. This number here, so my radius comes to be 0.0153 meters. Okay, so 730 divided by pi, all square rooted, gives me that. And then my diameter is going to be that times by 2 now. So I'm going to go 0.0153 times that by 2 gives me 0.036. That's my diameter in meters. That's your answer. And if you want that in millimeters, that equals 30.6 millimeter diameter. Okay, that's the diameter that I need. Dun, 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 dun. What does that mean? Good question. That just means that the diameter of this pipe coming out here needs to be about 30.6 mil diameter if we want 6.5 to come out of it. Okay, solve it off. So that is part B. Look, part B, the outlet diameter of the pipe, and the answer to that is 30.6 millimeter diameter pipe. Okay, we should probably have a 31 or a 32 because you can't get 30.6 mil, can you? Because you make it. You probably can get them. But... okay, make sure when you're doing this that you don't forget to multiply things by 2 because radius is half, isn't it? Okay. So that is working out the outlet diameter. The next one is how many litres coming through. Number of litres flowing in the pipe. That's part C. This is part B. Oh, this is part B done over and out. Part C is coming next. Part C, not part C, part C. We've done part B, done part A. So part C is the number of litres flowing in the pipe. Okay, how many litres are flowing through this pipe? We've done the mass flow rate, how many kilograms. We've done the outlet diameter. Now we need to know how many litres. 10 litres, 5 litres. Okay. So, part C, how many litres? How many litres? Because we can picture a litre. We all know how much a litre is. Okay, a litre of Coke, a litre of squash. So we need to know how many litres. So here's our pipe. I'm going to tapering. Yeah. So just like mass flow rate, the same amount of litres is passing through every second. So we can work out a thing called V dot, which you remember is volumetric flow rate. Okay, that's how many cubic meters of water or oil, whatever it is coming through a second. We've done mass flow rate, which is kilograms per second. This is how much cubic meters, volume of water, volume of alcohol, volume of oil, cubic meters per second, which is a good thing to know. But perhaps even better is how many litres. So we can work that out. Okay, the number of litres flowing. We also know that 1 cubic meter equals 1,000 litres. You just think of 1,000 litres. Huh? So a cubic meter of liquid is 1,000 litres, which is handy to know. First of all, we need to find the volumetric flow rate. The volumetric flow rate is quite easy. Volumetric flow rate is going to be, that's a dot, by the way, V dot, look. It's going to be area times by speed. So we know what A1 is and we know what C1 is because we did it before. We know now what A2 is and we know what C2 is, so we can work it out. So as long as you use inlet area or inlet speed, right? So we know that, where are we? A1, I'm going to use A1, right? Because I know A1. There's my A1 here, that number there. Okay, I know that number is. So A1 is there. Look, I haven't worked it out in this one. I've just, put the whole number in. Saves rounding up. So I know what my A1 is. Can I go back and solve that? Nope, nope, nope. Let me write in again. I worked it out. Pen, come on, pen. That was pi times by 0.0. So I know my A1. I know my area in. So I know area 1 and I know what my speed coming in is as well. So my area coming in is up here, look, pi r squared, pi up there, look here, pi r squared. You'll have that as well. And I know this, my speed coming in is 2 meters per second. So I'm going to use them numbers because I was sort of given them numbers. So I know they're correct. But you could do, if you wanted to, the outlet area and outlet speed. Okay, so volumetric flow rate is area times by speed. I'm doing the inlet area and the inlet speed. My inlet area from before was pi r squared, which is all of this. Saves rounding up. Look, so I've just put it in as the entire formula. Right. Pi r squared times by the speed coming in, which was 2. It was coming in at 2 meters per second. Look. This will give me my volumetric flow rate. How many cubic meters of liquid per second? Whack that in your calculator and you will get a number 4.752 times 10 to the minus 3. Not much, is it? Cubic meters per second. That's how many cubic meters a second is coming through. It's not a very big pipe because it's only 30.6 mil diameter coming out, isn't it? And it's only whatever it is coming in, 55. That's how many cubic meters is coming in. You could do the same thing and work it out for the out. It'll still be the same number because we've made it like that. So I know that there's 4.752 times 10 to the minus 3 cubic meters per second. I've got to find how many liters. So that's what I need to find. It's asking me how many litres. And with this little bit here, look, I know that 1 cubic metre is the same as 1,000 litres. So I can use that. So I know that 1 cubic metre is 1,000 litres, which means that 2 cubic metres would be 2 times 1,000. 2,000 litres. 2,000. Okay, so 4.752 times 10 to the minus 3 would be this many litres. You shouldn't really need a calculator for this. 4.752 times 10 to the minus 3, look. Times that by 1,000, because there's 1,000 litres in a cubic metre. Just get rid of that. So the answer, let's give a different colour pen. The answer is going to be 4.752 litres per second. That's how many litres per second? Almost 5 litres per second. So you can picture a litre, can you? So a litre of Coke, a litre of alcohol, a litre of blood. You know, when you go give blood, litres of blood, litres of oil. That's how many it is. So you can picture a litre. So it's 5 litres per second, which is quite a lot. And I think that's part C done, Wedi Benny. Have we done everything? Yeah, mass flow rate done, outlet diameter done, number of litres done. That's part A, part B, part C, all done. There we are. So go back, press pause, do it again, see how you get on. And that's the question on pipe flow. Okay, so over and out.